You know what this filter costs? $5. You know what this one costs? $30. And I know exactly which one you have been buying, because the packaging on this one says captures 99% of allergens, and this one says nothing. It is just white. So you grab the $30 one, feel responsible, go home, slide it in, and you just set a timer on your heating and cooling system. Not because the filter is bad at filtering, it is great at filtering. That is actually the problem. Stay with me. Let us start with something nobody in the filter aisle is going to tell you. Your heating and cooling filter was not designed for you. It was designed for your equipment. That might sound cold, but hear me out. Your system, a gas furnace paired with a central air conditioner, has a blower inside. That blower pulls air in, conditions it, and pushes it back through your house. It needs a steady, constant, unrestricted flow of air to do that. The filter sits at the return vent right before the blower. Its job is simple. Stop big particles from getting into the equipment. Dust, lint, debris. Keep the coil clean. Keep the blower clean. That is it. It is not a medical device. It is not an air purification system. It is a mesh barrier protecting a machine. Now here is where it gets interesting and a little infuriating. At some point, filter manufacturers realize something. People do not care about machines, but people care a lot about their families. So they repackaged a basic filtration product into a health product. And now you have got a filter aisle that looks like a pharmacy shelf. Captures microscopic allergens. Defends against airborne particles. For families with pets and asthma. These are not engineering claims. They are emotion-based marketing. And they are costing homeowners real money. Not just at the shelf, but in repair bills, they never connect back to the filter. Let us talk numbers, because this is where it all makes sense. There is a rating system for air filters called the minimum efficiency reporting value. Most people call it by its initials, but what it means is simple. It measures how small a particle the filter can catch. The scale runs from 1 to 16 in residential settings. Higher number means it catches smaller particles. A rating of 4 or below, that is old school fiberglass, the kind you can almost see through. Catches visible debris, not much else. A rating of 8, standard pleated filter, catches dust, pollen, mold spores, pet dander, works well, keeps your equipment clean. A rating of 11, a step up. Good for homes with lots of pets or people with moderate allergies. A rating of 13. This is the premium tier, marketed as near hospital grade. Catches very fine particles, including some that carry bacteria. Sounds like a clear upgrade, right? More filtration is better. Obvious choice, except here's the physics that no one on the packaging mentions. To catch smaller particles, the filter material has to be denser. Denser material means less space for air to pass through. Less space means more resistance. More resistance means your blower motor has to work significantly harder to pull the same volume of air. Engineers call this pressure drop. And every heating and cooling system has a design limit for it. Push past that limit, in most residential systems will exceed it with a top-tier 1-inch filter, and you start doing real damage. Your system was designed to move a specific amount of air per minute. Cut that airflow, and you are not just reducing comfort. You are changing the operating conditions for every single component in the system. So, what actually happens when airflow gets restricted? 3 things, and each one is expensive. First, the evaporator coil freezes. Your evaporator coil is the part inside the air handler that gets cold and pulls heat out of your air. For that to work, warm air has to flow across it continuously. Restrict that airflow, the coil gets too cold. Moisture in the air freezes right onto it. Ice forms. More ice forms. Soon, you have got a solid block of ice where your coil should be. The system runs non-stop. The house does not cool. And the homeowner has no idea why. Thawing and diagnosing a frozen coil is a service call. Cleaning or replacing a coil that has been operating in those conditions repeatedly, that is several hundred to over $1,000. Second, your blower motor burns out early. Motors that have to work against resistance run hotter. Heat degrades the motor windings over time. A blower motor that should last 15 to 20 years can fail in half that time if it has been fighting restricted airflow its whole life. Replacement, including labor, often runs $400 to $900. For high-efficiency electronically commutated motors, even more. Third, in gas furnaces, the heat exchanger cracks. This one matters beyond money. The heat exchanger is the metal chamber where combustion happens inside your gas furnace. It is designed to operate at a specific temperature, which depends on a specific amount of airflow running across it. Restrict that airflow, and the exchanger overheats on every single heating cycle. Metal expands and contracts over and over hundreds of times. Eventually it develops a crack. A cracked heat exchanger means combustion gases, including carbon monoxide, can leak directly into your living space. Any certified technician who finds a cracked heat exchanger is required to shut your furnace down on the spot. You cannot use it until it is repaired. Replacement can run into the thousands. In many cases, the technician will recommend replacing the entire furnace, anywhere from $4,000 to $7,000. All three of these failure modes share one common thread: restricted airflow. And a high-rated 1-inch filter in a system not designed for it is one of the most common causes. Let us run through the numbers quickly because this part surprises people. A premium filter, $25 to $35. Manufacturer says change it every 3 months, but here is what they leave out. A top-rated filter catches far more material than a basic pleated one, which means it clogs faster. Many heating and cooling professionals recommend changing them every 30 to 45 days in real-world conditions, not 90. So that quarterly filter, you might be replacing it 8 to 10 times a year. At $30 each, that is $240 to $300 annually, just in filters. Compare that to a quality, basic pleated filter at $5 to $8, changed every 90 days. That is $20 to $32 a year. And the cheap filter is not stressing your equipment. There is one more cost that is invisible until it is not: electricity. When your blower fights resistance, it draws more power. Studies have shown that high-rated filters and systems not designed for them can increase fan energy use by 15% or more. That adds up month after month on your utility bill. You are paying more for the filter. You are paying more for electricity. And you are accumulating equipment damage that eventually shows up as a repair bill with no obvious cause.